Now here the question is 7-digit numbers are formed using the digits 1, 2, 3, 4, 5, 6, 7, 8 and 9 without repetition. The probability of selecting a number such that product of any 5 consecutive digits is divisible by either 5 or 7 is P, then 12P is equal to. Now first we'll calculate total number of numbers that can be formed. Now total number of numbers that can be formed is simply 9C7, and then once we have these 7 digits, we can form these numbers in factorial 7 ways. So it will be this 36 into factorial 7, and that's our total number of ways. Now we'll calculate favorable number of cases, and for that what we'll do is we'll take 3 scenarios. Case 1, when we have not included 5 and we have not included 7 in the 7 numbers. So if we have not included 5 or 7, then we are left with 7 numbers. So in that case, total number of numbers that can be formed is factorial 7, and all these numbers, they won't be divisible by either 5 or 7. Now we'll consider the second case when exactly one of 5 or 7 is included. Now in this case, which one? So from these two, we'll select one. So it'll be 2C1, and then from the remaining 7, we have to select 6. So there'll be 7C6. Now it's a 7-digit number: 1, 2, 3, 4, 5, 6, and 7. Now it says any 5 consecutive digits is divisible by either 5 or 7. Now if we take 5 consecutive, it'll be this from this side, and it'll be this from the other side. Now if 5 or 7 they appear in the middle 3, then in that case those numbers will be either divisible by 5 or 7. Now we want the numbers which are not divisible by 5 or 7. So that means this 5 or 7, they must occupy a place from these 4 places. So for 5 we have to choose one place, and that can be done in 4C 1 ways. And then we can arrange these remaining 6 numbers in factorial 6 ways. So that's our second case when exactly one of 5 or 7 is included. So if there is no 5 and no 7, all the numbers are not divisible by 5 and 7. For second also, these are the cases where the number formed is not divisible by 5 or 7. We are solving this question using exclusion. And then this third case when both 5 or 7 are included. Now if both 5 and 7 are included, in that case, we already have 2 numbers. That means from the remaining 7, we have to select any 5. So there will be 7C5. Now the numbers formed by them must not be divisible by 5 or 7 for any 5 consecutive digits. So it can happen if number starts with 57, then we'll have 5 digits which are consecutive and not divisible by 5 or 7, or it can be 75, or it could be numbers ending with 57 or numbers ending with 75. Then there is this another possibility when number starts with 5 and ends with 7. So we have group of 5 which is not divisible, or is 7 and 5. So we'll have 6 cases in which we can position 5 and 7. So it will be this into 6, and then we can arrange these remaining 5 numbers in factorial 5 ways. So these are the possible cases where number formed is such that any 5 consecutive digits are not divisible by either 5 or 7. Now we'll calculate this probability using exclusion. So this probability will be 1 minus, now this is factorial 7 plus 2C1, 7C6, 4C1, factorial 6 plus 7C5 into 6 into factorial 5 divided by 36 factorial 7. Now this is 1 minus, now this is factorial 7. Now 7C6 is 7, and into factorial 6 is factorial 7, and this is 8. So it will be this 8 into factorial 7 and plus, now 6 into factorial 5 is factorial 6, and 7c5 is 7c2, and 7c2 is 7 into 3. So it will be this 3 into factorial 7 divided by 36 factorial 7. Now this factorial 7 will cancel. So we can write this as 1 minus 12 by 36, which is 2 by 3. So value of this probability is 2 by 3. Now we need to find the value of 12p. So 12p will be 12 into 2 by 3, which is nothing but 8, and that is the answer to this question.